Good morning, ladies and gentlemen. Today we're going to talk about how to dry complex building materials and some of the things that you'll run into in both commercial and residential settings, but primarily commercial settings because they're just a whole lot different. We'll go in and dry a house these days. Everybody can dry the model houses that are set up in the ASD schools across the country, and they can all be dried in quote unquote 3 days, and you can get in there and get out fast, but they don't have a lot of the materials in those that we're going to discuss today, and we're going to discuss how difficult some of these things are. So we're going to talk about foundations. We're going to talk about wall and ceiling drying and roofs and framing, and then some complex challenges that come with those. So let's get into it and start talking about those. The first thing we're going to talk about a little is foundations. And you say, well, why would I need to dry a foundation? Well, the same reason you'd need to dry anything else. Um, Several different types of foundations in buildings that you need to be aware of. You can have a basement, which can have various different foundations and crawl spaces design. You can have a open pier, which a site stick built would be the picture on the right that you can see. Of course, you have modular homes. Those are all together a different challenge with the way they're constructed. And then you can have panelized homes, which are getting more popular to where they're actually framed at a factory and they bring them in and set them in place on site. So you can have several different types there. Foundations can be, back in the old day, can be the beam sitting on rocks or blocks and just have like a post foundation. You can also have what's more typically seen is a block foundation all the way around the home with it sitting there. On a mobile home, they'll be on piers under the frame of the mobile home with typically a vinyl siding or some other type siding going from the bottom of the structure down to the ground. But we have to get in there and consider all of these things when we're talking about getting a structure dry. Um, Different types of foundations. We're going to talk about crawl spaces, basements, cinder block, poured concrete, formed foundations, concrete and cement, wood, slab on grade. We're going to talk about that a little bit more, and then piling and pier and beam uh, foundations. So several different types of foundations and footers and stuff that we need to talk about. Let's talk about drying foundations and or crawl spaces in general. The first thing that everyone listening to me will readily agree to is that adjusters do not want to pay for drying crawl space. They do not want to dry dirt. It's designed to be wet. Simply change your terminology. It works 100% of the time. You're not drying a crawl space. You're not drying the dirt. You're drying the floor joist under the house. So just retitle that room floor joist underneath the house, and that's what you're going to be drying. You won't get any kickback from that. The dirt will dry in the process, and everybody will be happy. But don't use the word crawl space, or you'll have trouble getting a little. You'll have trouble with the adjuster on it most of the time. They just don't understand that the floor joists under the house have to be dry, or they will form mold and bacteria growth and pretty much anything else because it's nasty down there to start with. Uh, you'll also have some concrete slab on grade. You'll see there on the right, and that's where you simply constructed properly would put gravel down and then put a vapor barrier, usually 6 mil plastic, on top of the gravel to stop moisture from coming up through the ground. And then you put your reinforcement in and then your concrete in. Of course, you don't know that they put a vapor barrier down there or that they did a good job or it didn't get moved around during pouring the concrete process. So you really don't know how good of a vapor barrier you've got beneath that because you obviously, can't get down there to look at it and to try to figure out what's going on with it. So, but when you're drying concrete, you have to consider those things. These are crawl spaces that we will typically see out in the field, which they're not all the real pretty ones that I was showing before on new construction. But you get on there and you're going to find a little bit of everything. If you'll notice in the picture to the left, you got insulation up, stuffed up between the floor joists. You've got where somebody's put extra support under there, a temporary support where the floor may have been sagging or maybe it was shaking when you walk across it, and just several different things that you're going to have to deal with. And now you got an inch or two of mud down there that you've got to deal with. Notice the dangling wires that are down there. That's not uncommon at all, but it is dangerous when you're in a wet environment. So you have to consider all that before entering a crawl space, and you should always have someone there on the outside when you're entering the crawl space. You look at the picture on the left, you actually got a pond dug under there for some reason. I have no idea why, but in this particular crawl space, it's just a big hole in there where they dug dirt out for some reason, and they left it there. And so when moisture from a broke pipe or whatever the cause may be gets into that pit, you've actually got a little pond there, and that will take a different type of extraction. And as you can see in both of the pictures up there, you've got an extreme amount of junk and crud and nastiness to deal with before you even get started. So you're fighting an uphill battle before you even get started on the job a little bit. So some of the smaller pictures down towards the bottom show different things and the way different construction methods are. Again, pictures on right and left are what you're going to see most of the time. You're going to see plastic that is not taped at the seams. It's improperly put in. I mean, they held this one down by rocks on the left. And typically when you get water in there, the water gets up under that plastic. And you can't get that moisture out without getting the vapor barrier removed. So you have to remove that vapor barrier if water's gotten underneath it. Now, some people would say, why are you removing it? Why are you worried about water underneath that? Well, I understand that dirt holds a certain amount of moisture, but before this damage occurred, you didn't have a pond under there. You didn't have inches and inches of dirt that's going to put out humidity and humid conditions all the time. So you have to get that reasonable before you put the plastic back down. I'm not going to tell you the dirt needs to be dry, but I am going to say it needs to be reasonable to where it's just not a gooey, muddy mess that you'll be dealing with. And then you'll have to put new plastic in. I hope you do a better job than these guys did when you put the plastic in. But insulation companies do that a lot as far as putting the plastic back. If it's put in completely properly, the seams would be taped, and not trying to necessarily create a seal, but just trying to hold it from coming apart like it has in these pictures. If you look at the picture to the right of the center of the screen there, the concrete block, and see where the moisture has wicked way up that block. So they got some water down there where the concrete is, but moisture is wicking up the cinder block and going up towards the framing. And that water can actually wick all the way up through that cinder block and get to the framing. Of course, it's pretty much a given that the framing down there is going to have an elevated moisture content because you got so much water sitting under it, and you got water wicking up the concrete pillar in the center and the concrete blocks all the way around it. And again, when you're dealing with the concrete block, it don't necessarily have to be as crispy dry as a piece of sheetrock would, but you got to get it reasonably dry. and back to normal moisture content because it will grow mold. I think most of you already know it, but you can grow mold on a piece of glass if you got dust on the glass. So, mold will find a food source and get on it. So this is something that you still have to contribute to controlling the environment in when you have a water damage, because it certainly wasn't that way before the water damage occurred. So you need to return it back to pre-loss condition. Different types of floor framing. You see some wood rot on the picture on the far right, where obviously that probably a shower above that or a commode nearby or something that's caused a more long-term damage above that. But your floor joists look in pretty good shape. Nevertheless, when you have water damage, that's got to be dealt with, whether it's covered part of the claim or not. But you still have to deal with that issue. If the wood has lost structural stability, then it obviously has to be replaced. If that's surface discoloration, you can treat the wood and try to get it cleaned up, and then simply dry it. Lots of different wood types of wood framing that you can have problems with. You see on the sill plates on your left. I've never seen that type of installation that's in that picture. Most of the time you'll see bolts coming down to hold that wood sill plate in place, and should be a vapor barrier of some sort between the plywood and the bottom of the 2x4 or 2x6 or whatever that sill plate is. So several different types of framing. And this typically you're working under the house, but once again, people think because you can't see it from the living room, it don't matter. But you've got to get these areas clean and dry to restore the property properly. So, a lot of different types of subfloor materials. You've got you can read them here, but you got Tire Rock, you got Delta Florida, you got Vantech, you got Dry Core, OSB, plywood, Amdry, Barricade, and of course the concrete slab. And it gives you the years here that it takes that material to reach equilibrium or the warranty to run out. So you've got a lot of different materials, and if you hadn't heard the saying before, you should have, but you can't dry what you don't know. So when you go into these houses, just because there's carpet on the floor, maybe sheet vinyl or hardwood or the new waterproof planks that you put down from Pergo and different companies such as that, you've still got to know what's under those floors to be able to dry them. And if you don't know what's there, you can't dry it. I mean, it's too difficult in too many situations. You're like, oh, well, I can't see through the floor. I can't get to it. Well, look at a floor register in the floor and try to pick one up and get to it there. You've got to find some place to get access to be able to get to those areas, to inspect them and find out what you're drying or what you're trying to dry and how you're going to dry it, and put together a drying plan. Why I say that, the IICRC says you must have a drying plan, and too often I see people that call with a problem, and I ask them for their drying plan, and they're like, a drying what? Oh, we're going to put some air movers and DUs in there, and we're going to dry it, and that's our plan. Well, where is it in writing? It's got to be part of your agreement. It's got to be part of your paperwork that you got to have a drying plan, and you put that plan together. But you can't write a plan until you know what you're going to be drying, what type of flooring. I'm sure some of you pulled up a vinyl floor and found underlayment under the vinyl floor, and then under the underlayment you found the old vinyl floor, and under that you found an old hardwood floor, and so forth and so on. And when all that gets wet, if you can't figure out what's down there, you can't dry it. It's like driving in the dark, so to speak. So other hidden areas can be beams above the ceiling. By the same token, you got to know what's above the ceiling. When you look up, you see sheetrock or drywall, or maybe a suspended tile ceiling or something. But you look up, that's all you see. But you got to know what's up there. And somebody will tell you, oh, there's just ceiling joists up there. Well, yeah, but what's on the ceiling joist? Is it do they have insulation up there? Do they have nothing else up there at all but sheetrock? And you've got to know what it is up there, and you've got to do some inspection for that. A lot of times you can take a light fixture down and move the light can around and put a camera up in there and maybe see what you're getting into. But regardless, it don't matter how you do it, you've got to develop a plan to be able to look in that space and see what you got. There may be a 2 foot void in there. There may be air conditioner ducts in there that are wrapped with insulation, and now that's gotten wet. And if you don't know what's up there, you cannot do a good job of drying the structure without finding the hidden pockets of water and stuff. And you got stairway there on the right, and see how it's constructed. It's got all kind of places in there for water to hide and to get trapped within that stairway that you've got in there. So you've got to know what kind of material you're dealing with there. It's also a great place that carpenters throw trash when they're building homes, and so you might have different wet things in there that can cause problems down the road. So once again, you just got to inspect what you're drying and know exactly what you are drying. So that's touching a little bit on foundations and some on some other stuff too. But you've got to know which type of foundations and crawl spaces and beams and posts you're drying, uh, and you've got to put together a plan on that. And as soon as you get a plan put together, then you can address each area individually. And you've got to look for this stuff. It's not going to poke its head out at you and tell you how it's built. You've got to dig in and find it. Talk a little more about walls and ceilings and floors. Some of the problem areas and complexities that we see there. Uh, Here's a cutout section of a wall that we want to talk about. If you start from the right and move your way back to the left, obviously you're going to have paint is the first thing you're going to see. How many layers? Is it elastic paint? Is it latex paint? Is it oil based paint? Is it got lead based paint? Maybe in some old buildings. But how many layers of paint do you have that you have to dry through? No, paint is breathable, and you can get evaporation through the paint. But obviously, the more coats of paint you got, the longer it takes to get evaporation to occur. You may want to consider, in some cases, removing the base and drilling holes and get air injected into the cavity of the wall. Then you've got vapor barrier that'll be somewhere in there. Normally speaking, it will be right behind the sheetrock in areas of warm weather. Up north, areas where the weather's colder, they may reverse that and put the vapor barrier on the outside wall of the building to stop the moisture from coming in. What you don't want to see when you do an inspection is a vapor barrier on both sides, because then you got trapped moisture. Once you get a water intrusion, you've got condensation that'll go on because you completely stop the area up and nothing can breathe. So you'll have a good condensation problem. Most all the time, we'll find mold in the house just from regular atmospheric conditions when you have two vapor barriers. So you want to keep that down and not encourage that. Or certainly, if you're doing any rebuilding or removing, you need to know it's there so you know how to deal with it. Um, then after you come through the where the stud wall and stud cavity is, to where you've got your insulation and stuff, then you've got your sheathing on the outside of the building, and they can be of several different materials. Typically, you see plywood or what they call OSB, which is compressed chips of wood glued together. Uh, in some older homes, you may have blackboard or tar board, or there's several names for it, but it's basically just a product with a lot of tar in it that's compressed It's lightweight. It's meant to be a vapor barrier and moisture barrier, but it does not have any strength to it. And in those homes, you'll have plywoods on the corners and around the doorways, and then you would have this black membrane board in between. It's just considerably cheaper than plywood, as reason contractors used it. And there was always that thought that it had a very good R value in the insulation. Then, if you've got a brick house, you're going to have a little airspace behind the brick and between the brick and the siding. That's designed for two reasons: designed for air and movement. It's also designed for water when the water comes through the brick after rain or what, because a brick will wick water pretty easily. The water has to have a place to run off. So you want like a Tyvek material on the plywood behind it, and then when you have condensation and the water can get on that and run down with gravity, and then you should have weep holes at the bottom of it to for the water to run out of. So you just need to know the components that you've got there and what you're trying to dry. Other types of siding may include lap siding, which typically can be wood. Of course, vinyl siding, we all know what that is. You can have slate siding, which is made of like a concrete board material, and in older homes, this typically contains a lot of asbestos. So if you have to remove some of that, or maybe it's been already been disturbed within the damage, make sure not to buy somebody else's problem when you had to deal with that. Here's a cutout of a wall section on the interior of what's probably like a motel or an office building, and you'll see that for sound deadening purposes and fire prevention and stuff, they got several layers here. Which got of course, your baseboard on the outside, your typical sheetrock, then a wall stud, and then on the inside they've got two more layers of sheetrock. Now, sheetrock is a fire barrier. It is rated for 5/8 sheetrock's rated for a half an hour fire barrier, which means if you put fire directly on that wall, it should not collapse till after a half an hour. You see two layers there on this picture on the inside, so that means that's an hour rated firewall. They've got two layers of 5/8 in there. And basically, what happens to the drywall has moisture, a certain amount of moisture in it from the factory, and then it retains moisture in the building. And what fire does to it is basically takes that moisture out of the sheetrock until it just don't hold up any longer. Of course, the paper can get scorched on the outside and break some of the strength down there. But the drywall is meant for a fire rating. Behind that, you'll see your exterior sheeting on the wall, and then another layer of or not exterior. I'm sorry, your styrofoam in the wall for sound deadening. It's actually a sound deadening board, and then on the back side of that, another layer of sheetrock. So, cumulatively speaking, that is about a 2-hour fire rated wall, and the sound deadening properties of that would be really good. Now, when we're talking about drying, we don't care about sound deadening that much. We don't care about anything but getting it dry, but just look at the difficulties that you've got in this one section of drying that. And if you don't inspect that, you don't know what you're drying, all you're doing is crossing your fingers at the end of the day or at the beginning of the day and hoping that it gets dry. And in some cases, if you don't know what you're drying and how that's constructed, you don't have a clue. You wouldn't even know that two layers of sheetrock was in the center of the wall there. You wouldn't know that you had the two layers of sheetrock even going below the floor surface there for insulation and fireproofing. So you've got to inspect that stuff and know what you're doing and what you're getting into. Sometimes it means you might have to have, you may have to do a little destructive testing on it. It means cutting a hole and looking in there and figuring out what you got. But right now, this problem belongs to the building owner and the insurance company. It's their problem. You're there to fix it. What you don't want to do is get a call to come back over there in 6 months from now, and now it's your problem, and you're expected to fix it because you did not properly dry it or you did not properly find it on your initial job site. So, if you miss some stuff like this in the house, it may cost you 100 grand. You miss something like this in a four-story hotel that's wet with 60 or 70 rooms in there, you probably got a bigger problem than that. So I would say inspect all of them equally, but your risk is a lot higher when you're dealing with hotels and motels and schools and office buildings just because the dollars are a lot bigger. Let's talk about gypsum, and it's called drywall on one day and sheetrock on another day. There's not a technical term for it. And we're going to talk two or three things about drywall, we'll call it for today. But it's gypsum board because the product in the middle is a chalky substance that is called gypsum. It has a chemical makeup that includes moisture, and it includes some silica, and it includes other things. So I've already touched on it a little bit that drywall has a fire rating property of 30 minutes for every 5/8 you put on. So how many thicknesses do you have in there? I've seen elevator shafts with 4, 5, 6, 7 layers. I don't know why they build an elevator shaft out of drywall, but they do. But once again, you got to inspect it. So when one gets really wet, it's extremely difficult to dry, number one. But number two, you shut down the entire building to try to dry the elevator shaft if they can't operate their elevators. So it's a big challenge to keep the business open while you're doing the drying and to be able to get in there and dry it correctly. So you've got to know how many layers of drywall that you're drying. I may have a slide on this a little later, may not, but there's green board, which is it's also called MR boards, called moisture resistant. Typically see that installed around showers and maybe around some vanities or something. You also got blue board, which is waterproof. You actually soak blue board in water and it won't hurt it. Out of all the drying that I've done in the years, I've only ran into one building that the entire building was blue board, and it was in Miami, Florida. And we didn't have any trouble whatsoever with the drywall getting dry. By the time the carpet and the baseboards and stuff were dry, the drywall was already dry because it don't hold moisture. It's very expensive. You don't see it very often. So, but if you ever run into blue board, that's what that is. Again, green board is moisture resistant. Blue board is waterproof. Um, you'll have all kinds of ceilings and just with floors and hidden spaces. You've got to know what you're drying. If you can't look above that ceiling and figure it out, you've got a problem. The ceiling tile here, it's typical installation. A lot of times that you'll have insulation sitting on top of the tile, and it's cut 2x2 or 2x4 or whatever size the tile is, and it's laid in there at the same time the ceiling tile is. It is typically unfaced insulation, so it's not really too hard to get to dry. Another thing about ceiling tiles that you need to be careful of is do they have asbestos in them? Are they ACM, asbestos containing materials? You'll see in a bunch of reports. Uh, if you walk into a building and you see ceiling tile laying on the floor from water damage, you immediately just set your scrubbers, set your dehumidification, don't put any air moving around it, and get a test done on it to see if it has asbestos containing materials. Because just as I said a while ago, when you walk through that door, this is the property owner's problem and the insurance company's problem. It is not yours. You set air movers across asbestos containing material, and now it becomes your problem. Now, differentiating between commercial and residential, to just look at the numbers of the business deal. Okay, you blow some asbestos around the house, you're going to have to deal with 3 or 4 or 5 people for the rest of your life with their health and their testings and all that kind of stuff. You do an office building that has 25 or 30 people working in it. Now you've got to deal with 25 or 30 families and have them tested once a year to see what's going on with them. And, it's just a lot bigger risk and a lot more to deal with. So you really have to be careful about asbestos materials in that. You also got to look above the ceiling and see how many other ceilings are above it. If it's an older building, maybe it's been remodeled 2 or 3 times. Maybe they built a building and then decided to put a drop ceiling in it. So you got to figure out what's above it. Most, even new construction, will have a fire rated sheetrock ceiling above the suspended tile ceiling. So you may have sheetrock, and most likely will have sheetrock above this suspended tile ceiling. It could be above it 6 inches, or it could be 6 or 7 or 8 feet, or even higher in the air. So you really can't even get up there to test it or to evaluate the sheetrock that's up there, because you can't get a ladder up through the grid work. You can't run a lift up through there. So you'll have some challenges doing that sometimes. Now, above that sheetrock ceiling that's way up there, may have faced insulation called bad insulation. Bad insulation has fiberglass insulation, which is extremely easy to dry because it's glass, it don't hold water. But when you put the paper backing on the fiberglass insulation, it's a piece of paper with tar sprayed on it. And they spray the tar at about probably 4 mil, and it's pretty thick, but it holds water. So when you put it above the ceiling, above the sheetrock, and you pour water on top of it from above for whatever cause of the damage is, now you've got ponds of water held inside the insulation that you can't get to. And there's no other way to get to it than to remove it. And if that means tearing the ceiling out, that's what it means. The only way you can detect it would be to take a hammer probe and go all the way through the sheetrock and all the way through the insulation, and to see if you have moisture in there with like the probes on a hammer probe or some type of long probe on your meter that you'd have to get in there. Other than that, you just have to take it out. So be careful when you get to dealing with suspended ceilings and different type of ceilings when you do that. Here's some of the types of insulation that you'll deal with. You've got the picture. I'll start on the left and go across. You've got plastic vapor barrier over there, which is a nightmare when it comes to drying because you can't dry through plastic. Your second one, you got Hypalon or some other type of spray-in insulation, creates the best moisture barrier that you can get because it's sprayed in and it leaves no gaps. There's 2 types of this spray insulation. One of them is porous and will hold water. The other one is dense and will not hold water. So you got to figure out which one you got. If it's porous, then if water can go in, water can come out. You can dry it. If it's the non-porous and water gets behind it between the plywood sheeting and the insulation, you can't dry it because it's sealed off. So you've got to figure out what you got and where your building's wet at. Then the other picture there just shows unfaced insulation that's being put in. The guy with a little hard hat on over there. So you got unfaced insulation going in the attic there. The one right below him where the guy's got the mask on is putting in the bad insulation that I referred to that's got a vapor barrier on it. And in the south where it's cold, you put that vapor barrier towards the living area. Up north where it's warm, you turn it around and put it towards the outside. So it depends on your climate. Then you got the pink insulation there, which is the insulation I was talking about, goes above the ceiling tile. That's a 2x4 block of insulation, and you just lay 1 block on top of each tile. Works good for sound deadening, and also for insulation. The silver wrapped insulation on the back, that's foil backed insulation. It's just a piece of several vapor barrier that got foil on it, typically seen in water pipes and or heating and air applications. But when you get water in that insulation and you've got that foil on there, they also tape that up with a foil tape. You're not going to get that water out. That insulation has to come out and be redone. So that's a little bit about floor construction and some ceiling construction and stuff like that. So we're going to talk a little bit more about hardwood floors here in a minute and talk about how they're built. Hardwood floors are built several different ways. Um, Once again, you have to know what you're drying. You see your glue down flooring up on the top, that's on typically on concrete, and you just simply spread glue like you would for gluing tile down, and then you install your hardwood on it, and it just lays there in the glue. The wood will dry. The glue will dry. If you have deep saturation, it may take the concrete a while to dry, but usually you can be pretty successful in that. The stapled down flooring you see on the other side has 2 or 3 different layers to it. You've got of course, your subfloor. Then you've got after your subfloor, a lot of times you'll see an underlayment there. It may be sometimes it's concrete board, sometimes it's just another layer of plywood. But then you put your finished floor on top of it and staple it down with a air gun usually, and get that stapled down. But needless to say, you've got 2 or 3 layers of flooring there to dry. The injector dry mats work really well on flooring. So if you're going to dry hardwood floors, then you probably want to invest in some injector dries. I would recommend never telling somebody you can positively get a floor dry within reason. I can tell them I'll get it dry, but I can't tell them it'll lay back down and look good. Wood has a memory, and once you get it dry, it'll either lay down or it won't. Now, on a staple floor, even if it lays back down, you still may have a little bit of rippling in the floor because once the wood swells and pulls the staple up, when you get it dry, the wood will try to lay down, but it can't because of the staple. So if you got some areas that are bowed up pretty good, you may get the wood dry, but may not can get it to go back down. So it still may need some repair work done to it. I don't have a slide on it here, but they make a hardwood floor system the way they design them in a lot of schools. They recess the concrete where the gym floor is by like 3 inches. And then around the perimeter of the floor is where your bleachers set and where people walk on the floor, but it's not designed to have hardwood on it. So basically, they've made a 3-inch deep pond that will hold water. The construction process on that would be to they lay plastic down in the recess 3-inch recess area, sometimes even 2 layers. Then they lay a piece of 5/8 plywood down all over the entire floor. It's not mechanically fastened, it's just laying there. Then they come back and lay another piece of 5/8 going the opposite direction on top of that. Again, not fastened, just laying there. And then they put the hardwood on top of that and they fasten the hardwood to the top sheet. And all that's good. It makes a great basketball floor. It's a floating floor. You got a little bit of give in it. The difficult part comes is if you get water on that floor or down under the floor, 2 things occur. Number one, you're trying to dry it out of a pond that you can't drain, so extraction is not possible. And number 2, you get it under that plastic that's under there when it runs under there and you can't get it out. Very difficult floor to dry. I'll tell most people once I get there and inspect it that the chances of success are very slim. You'll have some adjusters say, well, I know and I agree with you, but it's a $500,000 floor, and if I don't at least try to dry it, I'll get fired. And so sometimes they'll try to dry it, even though you've told them that you don't think it'll dry. But if you've got one that's built like in the picture here for the Hawks basketball floor, you can get some airflow under there. Once again, you've got to take up enough of the floor, maybe in a doorway or somewhere, to see how this thing's built, to see how you run your airflow. So if you're running airflow under this floor, you obviously want to run it from right to left of the picture and get as much air under it as you can. And then you would want to put injector dries on it or a mat system like that. And obviously, most of the time use desk and air on them just because the desk and air is drier. You hear about people building tents over these things. It's a pain in the butt. It makes it hard to work on and work under, and all it does is save a little bit of dehumidification. My recommendation is not to tent it, but simply to add enough dehumidification to compensate for the cubic feet and the extra height in the ceiling and not worry about it. So I think at the end of the day, your cost savings not going to be a whole lot difference either way. So a little bit of a recap of what we've done there and talked about, and we talked a little about plywood, but you got plywood and OSB, and they have different drying properties as well, so you have to be a little bit careful when you're working on that. Got different types of rafters and trusses on new construction. You say, well, why are we dealing with them? Well, if you have a roof leak and that stuff gets wet, I know it's in the attic, I know you can't see it, but it still has to be dealt with. And you've got to know the type of construction on your roof. You can have a flat roof, a shed type roof, a gamble, mansard, gable, hip. There's a lot of different type of roofs just to know the terminology of. Not saying one will dry differently than the other, but obviously heat rises, and so you're going to get most of your heat from your drying equipment up in there. And a lot of these roofs are they got vents in the end of them, and the insulation's down on the ceiling, and so you've got a unconditioned space above the insulation. So you may have to, if you need a closed drying environment, you may have to tape off those vents or plastic them off, and then introduce some heat and some drying measures as well in the attic if you've got wet decking up there and wet rafters and trusses and things. So look at the different layers and components of a flat roof, and you say, why do I need to know that? Well, you need to know that because if that roof gets breached and it gets water up under there, you've got to dry those layers of roofing. You can see several different issues with them, but they're all multiple layers of something that you've got to deal with. Some of them has insulation beneath it. You see the one on the far right on the modified bitumen roof is actually one of the most popular, but it's got the metal under it with the little troughs in it, and those troughs are just there to hold water. So, when you get those full of water, you can do a little bit of drying on that building, but if you don't get that water out from that metal and get that dried correctly, they could have root problems for months and months and years on down the road. So you've got to be careful when you're dealing with that. But you got to know your construction material. You got to know what's wet, and you got to know how to deal with it. Just another example, some several different types of roofs that you'll encounter and situations that you'll encounter. Roofs and flooring are the two that it's really no end to what you can find. And then even like I mentioned earlier, with ceilings and what's above them or floors and what's under them, roofs can be the same way. You might have one type of roof and they come over and instead of taking it apart and doing something else, they simply add more onto it. So, you may have 2 or 3 different roofs on the same system. So roofs can be difficult. They're most of the time overlooked because you're like, well, they're going to put a new roof on it. Why do I need to deal with it? No, that's not true. There's lots of different building components in there that need to be at the manufacturer's recommended moisture level before you go put the top coating on. You don't want to have a failure of a high dollar roof system because the insulation under it's wet, and when the seam started building up, it caused a failure of the roof to be attached to the product it was meant to be attached from. So you got to be really careful with that. A few different challenges we've run into that I want to talk about just a little bit and touch on them. This in Scott Erickson's house in Lake Tahoe, Nevada. Scott Erickson was a World Series winning baseball pitcher, if any of you know him, but he has hydronic heat in his flooring. And if you'll notice here with the little red tubes under the flooring there in the middle of the flooring, it's basically a big water heater that runs glycol through those. Glycol's water with antifreeze in it. But you run glycol through there and you heat that glycol, and it in turn heats the floor. It's a very slow heat, so it's not one that you can cut off and leave and come back home and fire it up right quick because it takes a long time to get warm. But it's also very cheap and effective. So the most economical heat you can have. You see them in a lot of places, such as Tahoe, and places that really don't need a lot of air conditioning because they don't have to put in any other system except that. The challenge to that's getting it dry. You've got a really extremely thick floor system here. You've got either wood or concrete underneath it. Then you've got protective mattings. Then you've got the hydronic hoses. And then you got something over the top of those hydronic hoses. Now, in this particular house, it had lightweight concrete poured on top of them, so the hoses were actually inside the concrete. But it's lightweight concrete, very porous. It holds a lot of moisture. You can't put floor covering on there to get the moisture level back at the appropriate level. So it has a lot of challenges to it. You can't drive your hammer probe in there because you might hit one of the tubes. Your other meters will not react properly if it's got metal in the slab. So you have to use an American standard testing method to be able to test concrete like that. It just creates a lot of challenges. It took us 32 days to dry this floor, but it was a ton cheaper than tearing it out. Had 3 or 4 rooms in it wet, but part of the construction challenge is when they ran the hydronic tubes in the floor, they didn't compartmentalize them by rooms. So had we tore one floor out, it would have affected the rooms that go under the walls and so forth and so on. So basically, we'd had to tear all the floors in the house out to be able to get the hydronic heating system fixed. So the decision was made that if it took 32 days to dry it, just to keep drying it. So a very slow process, but was a good, successful outcome. We did remove the hardwood surface on it and get down to the concrete, but we didn't have to remove any of the concrete on it. This is a job in Kirkwood, California, at a ski village. About a lot of complexities on this. One was the snow was about 6 foot deep when we first got there. This picture was taken after they'd removed a bunch of it, but had about 6 feet of snow. The biggest challenge we had is minus 40 degrees, 40 degrees below zero. So, that was a challenge on our equipment working, on our people. Was a challenge as far as getting the building stabilized where we could start the drying process. So, you got to be prepared for some of these challenges when you get that call. Bridgestone Firestone, a lot of complexities in that as well. The biggest thing there, if you see right out of the name, is we spent $14 million in 15 days. it's a challenge in itself. But when we first sit down at the table with Mr. Clyde Fish, who was the go-to man at Bridgestone, he had the contractor there doing the reconstruction. Of course, we were there helping the carpet cleaning service do the drying. And he said, we will have this building back in shape in 15 days and be back in business. If you're not going to be part of that process, you can leave through that door right there. And he pointed at the door we all came in. So, needless to say, the writing was on the wall, and we were given the challenge of getting it done. We did succeed in having them back in business in 15 days, and came out to be a really good project for everybody. But it round the clock working, lots of planes, trains, and automobiles to get it done. But when you're dealing in business, they're not emotional like people in houses are. They're driven by profit and getting back in business. That's what they want to do. And not only have the business to worry about, they got all their employees to worry about. You can't just lay off, 250 employees and say, we don't know when you'll be back. We're going to get the building in shape. So, their time is of the essence when it comes to commercial work. So a little bit of the complexities of it, trying to get on through it, not to bore you and keep you on there too long, but those are some of the complexities that we got that we run through there, and that you run into that you just need to be ready for. So hope you've gotten some out of today's presentation. You've got my phone number and my email address here. If you need me to follow up with anything, give me a call or send me a text or an email, and I'll get back with you. I'm Scott Tarpley. Thank you.